Hello, welcome back to this training on natural language processing. In this video, we will talk about a very important concept related to representing words as features, and it is called term frequency, inverse document frequency, often abbreviated as TF-IDF. TF-IDF is one of the most popular ways of representing documents as features or documents as vectors. And there are two things which make it very popular. It's very easy to interpret and super easy to calculate as well. So without wasting further time, let's get going. So the TF-IDF concept, or the term frequency, inverse document frequency concept, it actually relies on the concept of the document term matrix and the bag of words model, which we discussed in some of the previous videos. What it does is it aims to solve a few of the issues that we run into using the term frequency model from the document term matrix. Now, if you think of the term frequency model in the document term matrix, the way the terms or the words or the tokens or whatever you may call it, the way they are given scores is purely based on their frequencies. So if a particular word is present twice in a given document or in a given record, then the score will be 2 for that word in that particular document, and so on and so forth. So it's by and large a frequency driven approach. Now think of a perspective that if there is in the data that you're handling, if there is a particular word which occurs across most of the documents. So let's say if you have 1,000 documents and you have a word which occurs in let's say 800 out of those 1,000 documents, so 80% of the documents have that word, then quite naturally the term frequency of that word will turn out to be quite high across all the documents, right? And a scenario like this, is not something that is far from reality. I mean, when you handle real data, you can actually come across such situations. So, for example, if you are looking at data of mobile phone reviews in any of the e-commerce websites or any of the e-commerce apps, obviously in all of those review collections, the term mobile will appear a significant number of times, right? Because it's the context word, it's the domain word, that is what for which the reviews are being written. So these kind of scenarios you can come across. Now, as far as the term frequency approach is concerned, it will give it a very high score, a very high value in the document term matrix across all documents. So the question to answer is, is that good? Is there issue in doing that? If so, then what is the issue and how do we basically get it solved? We will do a very quick recap of the document term matrix and the bag of words model, like we do in most of the videos. So we have a data set which have, let's say, n observations, and which we will call as documents, and there are p unique words or tokens in all of those documents taken together, and this collection of unique words and tokens is often called vocabulary, and a number of such unique tokens or words, which in this case we are denoting as p, is called the size of the vocabulary. And in this case, the document term matrix will be of order n by p. So there will be n rows, each row denoting one observation or one document, and there will be p columns, each column denoting one of the unique tokens from the collection of all unique tokens. So, and if you see in the slide over here, there are certain words which are being underlined with red, and it has been purposefully done because these are some of the keywords in the context of natural language processing, and whatever literature you might refer, or even during the course of this training, as we go down to the subsequent videos, we will very often make use of these keywords, and at times maybe I'll not even go ahead and describe them in detail, but so it makes sense, at this stage to take a note of the keywords and also to understand what these words mean. So this DTM, the ijth element of the DTM, which will be the element corresponding to row number I and the column number J, this actually means that number of times the jth word is present in the ith document. And the example that we were referring to right at the beginning, that if we are talking about all mobile phone reviews from the e-commerce apps, then obviously we will see that wherever we encounter the word mobile in the document term matrix, that column will have significantly high values across all the rows, most of the rows, because it's expected that the term mobile will occur in most of the rows because we are talking about a mobile phone review. So let's look at an example and see how it turns out to be. So let's say this is a collection of restaurant reviews, and for the sake of illustration, let's consider there are just 4 reviews, and this is what the reviews look like. So the first review says that the food was great, but portions were small. Well, that's a pity. The second review says that like the place, great food at great price. And the third review says good food but service was slow. And the fourth review says we'll visit again, liked it. Right? So this is again a uh, handcrafted example. Typically reviews won't be so small, particularly if it is a restaurant review, but just for the sake of illustration, I have kept them small out here. So if we construct the document term matrix out of this data, so we will have 4 rows here because we are considering 4 reviews, and we will have as many columns as are the number of unique words that we have in this collection of 4 reviews. So I have not written down all of them. So we'll have food, great, portions, small, liked, so on and so forth. And against each of these words in each of the rows, we will have the frequencies, the term frequencies. So for example, food in the first column, first row, it means that number of times the word food appears in review 1. Again, if I'm looking at uh, the word small out here, we see 1 over here because small appears once in the first row, but it never appears again in any of the subsequent reviews. So one of the things that we immediately see out here is that the word food, it appears in almost all of the documents. So in this case, that's 3 out of 4, 75% of the documents. So, and which is expected because we are looking at a restaurant review data, and it's expected that the word food will appear across multiple documents. So what problem does it run into? If I follow the term frequency approach, I will give food a very high frequency or high score across most of the documents. Now, which perhaps is not desirable because uh, if the term food here, it doesn't discriminate or doesn't help us distinguish one review from other. So it's a context word, it's a domain word. We know that it's food which is being talked about. So more than the word food here, what is being talked about food is more important. So giving food a high score across all the documents doesn't serve the purpose. So, and you can draw an analogy out here as well. I mean, if you think of, let's say you are doing a regression, a logistic regression with numeric data and categorical data, and there is one particular variable which has uniformly high values, across both the two uh, values of the target variable 1 0. Will that variable at all be predictive? No, right? Because I mean it doesn't discriminate between the ones and the zeros. Similarly, in a document term matrix, if you have such terms which are having uniformly high values across all rows, it may not be very useful for the subsequent analysis that you want to do. And end of the day, the document term matrix, it's actually a enabler, right? It's actually a initial analysis that you're doing for the purpose of doing something deeper. It can be building model with text data, it can be building classifiers, it can be doing text clustering, whatever that be. But you want to do something with your text data for which you are doing the DTM. You are not doing it just for the sake of doing it. So we must do it in a way so that the term frequencies that we get, they are kind of useful for the subsequent analysis. So the main problem with the term frequency approach is that it scales up the frequent term and scales down the rare terms. Now, on the contrary, it is the rare terms which can at times, and in fact most times, be more important to identify because they might show different trends compared to the values which or the words which are abundantly available in the document that you are handling. So something has to be done, right? I mean, if we go ahead with term frequency approach, it just takes into account the frequencies, and it will weigh up the more abundant words, and it will significantly weigh down or scale down the rare words. So there has to be another component which can do a balancing act out here, so that the words which are very frequently occurring uh, and are scaled up by the term frequency can be to an extent scaled down, and the words which are rare words which the term frequency approach doesn't give any weightage at all, they can be scaled up a little bit. So the question is, how do we achieve that? And the answer to that question is IDF, or inverse document frequency. So So we will define formally, how to calculate the inverse document frequency, and subsequently how to calculate the TF-IDF. But uh, the two biases which we were discussing about the term frequency approach, one of them is, it's biased by the length of the document. So the moment you are counting frequency of words in a document, it will be biased by the length of the document as well. Because if let's say if you have a review which is 10 sentences long, vis-a-vis if you have a review which is 50 sentences long, obviously some of the words will have higher chances of occurring and with higher frequency in the review, which is the lengthier review than the review which is the shorter review. So what happens is term frequency is also sort of impacted by the length of the document, number of words which are there in the document. And obviously the second bias is the more important bias, which we were seeing in the example before, that if a word is present across most of the documents in the data that you are handling, the term frequency approach will scale it up to a significant extent. So these are the two biases of the term frequency approach that we will try and solve. The first is relatively easy to solve, because if you simply normalize the term frequencies for a given document by the total number of words present in the document, then it serves the purpose. So for example, if you are handling a document or a particular observation in the dataset which has 50 words, and then instead of counting the term frequency, you basically divide all the term frequencies by 50. So 50 is the total number of words in the document, and then it obviously normalizes and eliminates the bias due to size of the document. So essentially, in the elements of the document are matrix. You are, instead of looking at the frequencies, you are now looking at the proportions, and they all add up to one. So the row, so if you do just this part, then all the rows of the documentum matrix will add up to one, because you are representing the words as a proportion of total number of words present in that document, so which reduces the bias due to size of the document. The second problem, which is uh, kind of more tricky to solve, is what to do if there are certain words which are present across most of the documents in the data. So for that, we define something which is called the inverse document frequency. And it's basically a scaling down factor which is defined as uh, log of total number of documents divided by number of documents having that particular term t. So if you're talking of an individual term, the inverse document frequency of that term will be the logarithmic of a quantity, and the quantity has in the numerator total number of documents, and it has in the denominator number of documents which actually have that word. So in a way, if you uh, think of it in simple words, you first look at, for a given word, if you want to calculate the inverse document frequency, the way to interpret that is you first look at a word and then find that how many documents are there in your data which contains that word. Okay, and then you can divide it by the total number of documents. So that will give you the proportion of documents in your data which contains that particular word. Now, instead of taking the log of that proportion, we are actually taking log of the reciprocal of that proportion. And the reason being, if you take a log of that, one of the reason being, I mean, if you take a log of that proportion, this term gets negative because it's a fraction. So, and if you take the log of the reciprocal of that, then you get a positive term because it's more than one, right? So that's something that we are following out in calculating the inverse document frequency of every term. So satisfy yourself that you understood and you interpreted this expression. So you're basically, for a given term, you're finding out a number of documents where that term is present, and then you're dividing that by the total number of documents. So you're essentially calculating the percentage of documents or the proportion of documents in your entire data where that particular word is present, and then instead of taking log of that, you are basically doing a reciprocal of that because that's a proportion and you don't want the scaling factor to be negative. You take a reciprocal of that and then you calculate the log of that, and that gives you the scaling down factor. And and TF-IDF will basically be TF multiplied by the IDF factor. Okay, so couple of more things here to focus on, and important things. So first thing is, if you talk about term frequency of a word in your data, even after you normalize it, the term frequency of the word will vary from uh, row to row in the document term matrix, right? And it's quite intuitive why it will happen that way, because one word may be present a certain number of times in one of the documents, but as far as when it comes to the second document, it may be present a different number of times, and it may not be present at all for that matter. So when it comes to term frequency, even if you normalize it or you do not normalize it, whatever you do, I mean, its value will, term frequency of a word will vary from row to row in the document term matrix. But the inverse document frequency of a word, that doesn't vary from row to row. So because if you look at the focus on the formula out here, it basically talks about what is the proportion of documents in which that word is present, and then you calculate the reciprocal of that and get the log of that. So the inverse document frequency is something which obviously will vary from term to term, because it's a scaling down factor for every term in the data, but it doesn't it varies from term to term, but it doesn't vary from row to row of the document term matrix, right? It's so basically every term in your data, it gets a scaling factor, scaling down or scaling up factor, uh, which is the IDF, and that can be applied on wherever you are calculating the term frequency of a term. Any document you're calculating the term frequency of a term, you can apply that scaling factor, which is the IDF. Another important point to note is, we have been telling that IDF is a scaling factor. Right now, what are the kind of values that IDF can take? So let's say if you have a document, if you have a term or a word which is uh, extremely abundant in the data that you are handling. And let's think of an extreme case that you have a word which is present in all the documents. So in that case, this fraction actually turns out to be 1, right? Because if it is present in all the documents, then obviously the proportion of documents in which a term is present turns out to be 1, and the IDF factor turns out to be 0. So, so what that means is, if a term is present in all the documents, then you are basically scaling its frequency to 0 by multiplying it by the IDF, which in that particular case will become 0. And that's a logical thing to do, because if you have a term which is present in all the documents, I mean, honestly, it will be of no use, because I mean, it doesn't discriminate the data in any way, for that matter. On the other hand, if you have a document which if you have a term which is very rare, let's say it's present in only few of the documents from the entire collection of documents, then uh, obviously this proportion, the proportion of documents where that term is present, that will be very small, and the quantity of here will be a large quantity, right? Because we are taking 1 by a very small fraction, and then the log of that will also be large, because log is a monotonic function. So mm, the inverse document frequency will be large, in the sense that if a word is a very rarely occurring word in your document, then the inverse document frequency, the way it has been designed, it will actually scale up the weight of that particular word. So whenever that word is present in any document, uh, the term frequency of the word will be multiplied by a larger factor, which being the IDF of that word. Okay, so that is how the mathematically IDF is. It's a very simple formula. I mean, it doesn't look scary at all, but then the job it performs is incredible and is very intuitive, and it actually serves the purpose in eliminating the biases which the term frequency approach have. So in a way, TF-IDF does eliminate the factor that term frequency would scale up words which are more abundant and scale down words which are rare. So uh, it not only takes into account, so the term frequency just takes into account the frequency of the terms, but the inverse document frequency, it also looks into the document view of that, and finds out that if a term is rare in the document, then it has to be appropriately scaled up. So going back to this example, we were looking at this example previously in this video. This was the restaurant review example, where we had 4 reviews for the purpose of illustration of some restaurant, and people were talking about how the food was. And obviously, I mean, if you're talking about a restaurant, amongst any other things, you'll obviously talk about the food in the review, and that's why we saw that in the document term matrix, the word food was present in 3 of the 4 rows. And if we would have gone ahead and calculated the document term matrix by taking just the term frequencies, it would have looked like this, right? But now that we know what inverse document frequency does, we will calculate the inverse document frequency of the word food out here. And how will we do it? So we will first calculate the proportion of records, or the proportion of documents where the word food is present. So there are 4 documents and food is present in 3 of them. So 3 by 4 is the proportion. We will take the reciprocal of that, which becomes 4 by 3, and then we will get the logarithm of that. By the way, the logarithm here is has a base of e. So when we calculate the logarithm of that, it turns out to be a value 0.2876, which is a small value. So what it is doing is, whenever I get the word food in the document term matrix and I calculate the term frequency, I actually scale it down by the factor 0.2876. So it has a scaling down effect in this case, and the reason it has a scaling down effect in this case is because food here is an abundant word. Now instead of looking at food, let's say if we would have looked at the word portion, then the IDF value would have been something different. So the word portion is present in only one of the four reviews, and hence we would have looked at uh, a log of 4 by 1, right? And that would have been 2 log 2, and and definitely a value that would have been a value higher than 0.2876. So in that case, if we have been looking at the word portion or small, the role of the IDF would have been, scaling up the term frequency. However, in case of the word food, because it is an abundant word in this data, the role of the IDF is to scale down the term frequency of the word food. So I hope that illustrates fully how the inverse document frequency performs in scaling up or scaling down the term frequencies of different words, depending on whether that word is an abundant word in the data or it's a rare word. And as I was mentioning in the beginning of this video, the TF-IDF is perhaps the most popular of all the approaches that are used in representing words by some features or representing words in a numeric way in natural language processing. And the reason for its popularity is twofold. One, as you can see, it is very simple to calculate. It doesn't involve any memory hungry computation, and it has a very straightforward and very intuitive interpretation. So that's about TF-IDF. As for most of the other concepts that we discuss for TF-IDF as well, we will do a hands-on with R, and we'll try and find out that how the TF-IDF is actually calculated in R, and how the DTM, the components of the document term matrix changes from the term frequency to the TF-IDF once we do the calculations in R. So stay tuned for the hands-on. We will most likely do that in the next video. If not in the next, we'll do it in the next to next video. Hope you understood and enjoyed this session on TF-IDF. Thank you for watching. Stay tuned for more videos to come. Goodbye.